Alright, so cloudification of large images under 1 minute. So this is about mapping between a Picker API, which is supported by most cloud providers, Google, Amazon, Microsoft, etc. And an API that functionalizes some aspect of the image. In this case, we'll be traversing a large image and extracting slices at different resolutions. So here we go. This is the application that illustrates this cloudification. And by default, we'll be loading an image from the glioblastoma multiform project of the Cancer Genome Atlas. So the important link in this page is this one that is highlighted in yellow. So if you click here, a new tab will be open with the URL composed already as an API. And it's interesting to note that at this level, we are looking at an image that is public, it is in the public domain. But we'll be seeing that by exploring the way a file picker API works, which creates a temporary URL, so a URI we can dereference for a finite amount of time, we'll be able to preserve the confidentiality or the privacy of this information. So just to make sure you believe me that this is public data, if I go here, this is straight from the Cancer Institute, NCI, we get a list of images. So we are pulling the data from here. We could, I guess, say that NCI is acting as a cloud here, and we are moving it here. Now let's do it from one of these box providers. So put here some links for the others. I implemented this file picker API conversion for Dropbox and Box.com. It's fairly easy. You can find it for others. So here we go. Let's choose Box. I'm going to pick another image. So notice we have the address here, but you'll see that the dereferenceable URI in the cloudified API is going to be different. The first time we do this, the large images to migrate between two cloud providers, in this case, the cloud provider behind Box.com and the place where GitHub serves content. There we are, so we had 111 megabytes transferred in at the rate of 10 megabytes per second. And at this point, we can traverse this image very quickly. See, there we are. Let's go back to the low resolution or the high resolution and change this value, say 10,000. This would be a very large image. So we are starting at position 10,000 and then we're extracting, say, 1,000 by 1,000. It's 1 million pixels. And there we are. I could say, well, it's an interesting image. Maybe it's a little bit further to the upper left corner. So let's reduce this. 9,000. 9,000, so going up in both directions. Okay, so this is more interesting. So the demonstration that this prototype application delivers is the mapping between the two APIs. So I'm going not to expose the fully composed URL with the API at the end. And you'll see here the interesting feature of file picker APIs is that they create a long string that is unique to that instance of retrieving a file. So the fact that this is done once, when it's done twice or in another machine, we'll have another long string here. So in effect, this acts like an API key. At the very end, we have the little API we implemented. So this is the cloudified functionality we are exploring in this particular example, where we have the width, the height, and the initial position of the square we are extracting, and also the scale. Now let's pick this link and say go to a place where we would be using this API. For instance, MATLAB, it's a popular environment for image analysis. And let's see how hard would it be to get this image. Not hard at all. And the important thing to remember is that we now have a dereferenceable URL with an API at the very end where the access to the file depends on the user having been privy to this long string which maintains the privacy of the file that was cloudified in the process. The same approach could, of course, be applied to other large files and to other functionalities. The key feature is that there is a core API, the Picker API, that enables the elaboration of or the derivation of APIs for other functionalities on top of that core functionality.